On behalf of RBCS, Software Test Works, and the software test professionals, we welcome everyone today to this webinar on ISTQB Advanced Technical Test Analyst. I am Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has been both a pioneer and leader in quality hardware and software testing. RBCS has offices in the United States and Sri Lanka with partners around the world. RBCS delivers insight and confidence to our clients, helping them get quality software and hardware products to market on time and with measurable return on investment. RBCS has a team of international consultants that deliver customized training, consulting, and outsourcing services for companies that are looking to improve their testing and quality assurance practices. RBCS has helped hundreds of companies reduce their development and support costs while assuring the best quality products are delivered to customers. I'm the author of Pragmatic Software Testing, Advanced Software Testing Volumes 1, 2, and 3, Foundations of Software Testing, Critical Testing Processes, and Managing the Testing Process. I have a degree in Computer Science and Engineering from UCLA, and I'm the past president of the International Software Testing Qualifications Board, or ISTQB, and the American Software Testing Qualifications Board. RBCS is presenting this webinar in partnership with software test professionals. In addition to our ongoing collaboration on webinars and training, I will be the opening keynote speaker at the Software Test Professionals Fall Conference on October 25th in Dallas, Texas. Hope to see you all there. In addition, if you haven't visited their association website, make sure you check it out as well. That is www.softwaretestpro.com. That's softwaretestpro, all one word, .com. Before we start the presentation, a couple of housekeeping notes. If you have any questions during the course of the webinar, you can submit them at any time during the presentation via your webinar interface. There's a little Q&A tab that you can access, submit those questions, and I will take them at the end. You do not need to ask the number one asked question, which is, how do I get a copy of this presentation? The presentation is already posted on the RBCS website. That's rbcs-us.com. Go to the resources page, go to the basic library on the resources page, and you will find there at the bottom of the page the PDF of the presentation. There's also no need to ask about how to register for the free e-learning course that will be given away to one lucky attendee of this webinar. Simply attending the webinar, you are automatically registered. Check your email over the next couple days and watch the spam filter to make sure the notification doesn't get lost there. You do have a limited amount of time to respond if you are the winner. If you are having any problems with the audio or visual components of this webinar, please contact GoToWebinar support. You might also want to check the Windows audio settings. Sometimes people reported echo associated with having the playback volume up too high. Be some weirdness sometimes when you're doing this over voice over IP. If for whatever reason you can't get to the webinar online or you've got an unreliable connection, you can download the slides. As I said, they are on the basic library, and then use telephone to connect rather than voice over IP, and you can follow along. Hope you enjoy this free webinar from RBCS. We do these as a service to the software testing community. At RBCS, we're a not-just-for-profit company. All right, so today's presentation is on the ISTQB Advanced Technical Test Analyst certification. This is one of 3 certifications at the advanced level, and the other 2 being the test manager and the test analyst, more business-focused test analyst certification. Now, we've seen increasing interest in this program since we introduced it in the last year or so, and today I'm going to give an overview of this module for you. For those of you who are interested, it seems to be a fairly large number attending today, so it's good to see you all here. Okay, so as I said, you've got the Advanced Test Manager, you've got Advanced Test Analyst, and you've got the Advanced Technical Test Analyst. You'll hear those referred to as shown here, either at ATM or CTAL, which stands for Certified Tester Advanced Level, and then -TM or -TA in the case of the Test Analyst, or -TTA in the case of the Technical Test Analyst. And if you get all 3 certifications, then you get an additional 3rd or 4th certification, which is called the CTAL Full, meaning that you have the full advanced level. which is quite an accomplishment because the range of material that's covered there from a management point of view to a business-focused testing point of view through to a technical point of view is quite sophisticated. So if you can get to all three and get the CTA full, that's quite an accomplishment. Now, up until fairly recently, there were not a whole lot of people at the technical test analyst level, advanced level, but that is changing, and we're happy to be part of why that's changing. We've seen a fair amount of uptake of our technical test analyst course around the world, and including here in the United States. And in fact, we are the only training company to offer the technical test analyst course in North America. So let's go through and take a look at what's involved in this advanced technical test analyst, including going through a quick excerpt of some training that out of our advanced technical test analyst training course, and look at a sample exam question as well. Now, first off, to look at the advanced syllabus here. There are 10 chapters in the advanced syllabus, which are partitioned across the 3 modules. By partitioned, I mean that there are a specific set of learning objectives that are defined for the modules, and in some cases, for a particular chapter, there are no learning objectives applicable to that module. So we can say, for example, that the advanced technical test analyst, if you look at the learning objectives, they are focused on Chapter 2, testing processes, a little bit of Chapter 3 in test management, just the part on risk-based testing is what you see covered. And then very heavily test techniques, a considerable amount of material there, as you would expect. It's technical test analyst, very much a white box approach in a lot of ways to thinking about testing. Testing of software characteristics, that has to do with understanding how to apply the techniques to evaluate the quality characteristics of a particular piece of software. So it's putting the techniques into action. And then there's some discussion of the technical test analyst about reviews, for example, code reviews and design reviews, which the technical test analyst will be expected to be able to participate in. So material on incident or defect management, life cycle and classification, and gathering metrics from defect databases. Chapter 8, standards and test process improvement, is covered entirely at the manager level, so is not in scope for the advanced technical test analyst. The same is true of Chapter 10. There is a considerable amount of focus in the technical test analyst on test tools and automation. So good conceptual understanding of things like keyword-driven testing and performance testing, reliability testing, and so forth using tools. Now, sort of a quick by-the-numbers analysis of the technical test analyst, the advanced syllabus. Generally, there are 114 pages in the advanced syllabus, and if you look at the learning objectives, which are the specific things that you're expected to learn and thus to be examined on, the test manager has the highest number of learning objectives, 64, 43 at a K2 level, and then 12 at a K3 and 9 at a K4. So you see that the technical test analyst is actually kind of midway between that, and has almost as many K3 and K4 learning objectives associated with it. And I'll discuss these learning objectives and those K levels here in just a minute. There are 21 referenced books, so for any topic that is discussed in some depth at the advanced level, there are references provided if you would like further reading. And there are 7 reference standards, so if you think that there might be some standards out there that can help you bootstrap your testing program in some way, then those are referenced and available to you. Now, in terms of the learning objectives, just to be clear about that so that you can understand what you're getting into, as it were, there are 4 levels of learning objectives that are defined in the foundation and advanced levels of the ISTQB program. And they are at an increasing degree of sophistication, and meaning that they kind of one builds on the other. So K1 just has to do with basic recollection. Can you remember that there is a technique called decision coverage, for example? Remember what the coverage criteria is for decision coverage. Every decision in a piece of code has been taken both true branch and false branch. Now K2, understanding. So that's a level up, because not only you have to remember something, you have to remember a concept, but also you have to understand what it means. So it's not enough just to remember that say, for example, decision coverage means that every branch has been taken, both the true side and the false side. You'd also have to understand that looking at a code coverage result that said, okay, 100% decision coverage been achieved, and you could say, okay, well, I could then understand that meant that every place there was an if statement, the true and the false side had been taken, and in every case there was a switch case construct, all the case blocks, including the default block, had been activated, and so forth. So it's really understanding what that coverage means. K3 is the application of a technique or a concept, and again, it requires the K1 and the K2. So in terms of K3, this would be to go back to the example of decision coverage, to actually set up a tool to measure code coverage at the decision level, and then run a set of tests and determine whether that 100% decision coverage had indeed been achieved. K4 is analysis of a situation, and that's above K3 as well, because let's say that you find that a piece of code has not been covered at a 100% decision coverage level, then K4 would involve being able to go back through your set of tests and actually determine what tests would need to be analyzed or need to be added in order to reach the previously unreached pieces of code, the branches that had not been taken or decisions that had not been taken. So for those of you listening who have the foundation, here's an important thing to remember. Most of the foundation questions are K1 or K2. There are very few K3 questions, and that's not the same at the advanced level. So, study strategy at the foundation level, which is just trying to make sure that you've understood a lot of concepts and memorized a lot of terms and techniques and so forth. That study strategy will not suffice for the advanced level exams. So those of you who've taken an advanced exam know what I'm talking about, that there are questions on there that are testing at the higher levels, and will require that higher degree of understanding. Now, one thing to keep in mind, this is something that those of you who are planning on taking any advanced exam, including the technical test analyst, the entire advanced syllabus is implicitly covered at the K1 level. What that means is that you do have to read and have a basic recollection of everything that's in the advanced syllabus for any of the exams, even the chapters for which no learning objectives are explicitly defined. We have some people that have gotten tripped up on this in exams, so it's very important to remember that if you're going to take an advanced exam. It's also important to remember that each module, the test manager, the test analyst, the technical test analyst, have their own set of K2, K3, and K4 learning objectives. There is very little commonality, and I'm going to get into that in a minute and explain why I say that. But you do want to make sure that you refer to the learning objectives in the syllabus, understand that, because that's focus your attention from an exam point of view. Okay, as I said, the advanced exam questions very much more focused on the K3 and K4, in other words, application and analysis, rather than recollection and understanding. Now, Now, that doesn't mean you don't have to remember and understand things, obviously. In order to be able to use or apply a technique or to analyze a situation where the technique is to be applied or has been applied and understand what that means, then you do have to have that recollection and understanding as well. But it's just you're not going to get any questions where all you have to do, or well, you're going to get very few questions where all you have to do is remember something or maybe understand something. It's more focused on application and analysis. Now, exam questions at the advanced level can also be what are called scenario questions. And a scenario question is where they describe a scenario at first and then ask you a sequence of questions about it. So, for example, it might say, you know, assume that you are testing a program that contains the following function, and then you might see a piece of C or C++ or Java code. Probably not a particularly complicated piece of code, but you know, maybe half a page long, and something that's not trivial either. And then you would be asked a question like, you know, which of the following set of inputs to the function's arguments will achieve 100% statement coverage? Which of the following will achieve multiple condition coverage? You know, there might be 3 or 4 questions that ask you about various code coverage related questions about the level of coverage you might want to achieve against that piece of code. Now, in a scenario question, it's very important that you understand the scenario before you start tackling the questions. Read those carefully. And of course, this is a good simulation of real life, because that's, you know, in real life, this is exactly what you would be looking at. You'd be looking at a piece of code and say you're a tester on an agile team, and you've got some sort of you know, unit testing harness going on, and you're looking at some code, and you're looking at the percentage of various kinds of levels of code coverage that are being achieved according to some tool, and you need to be able to say, okay, well, what's missing? I mean, we're not getting to 100% decision coverage, say, or we're not getting to you know, 100% modified condition decision coverage. Why is that? So, you know, particularly in agile teams, especially, you see a lot more emphasis on people being able to read code and being more technical. So this is a very real world type of situation. Now, I also want to mention the entire foundation syllabus is examinable at the advanced level. You can get a question off of any of the material, even Chapter 5 of the foundation, which is test management, on the advanced technical test analyst. So we always encourage people in our technical test analyst training courses to be careful to go back and review all of the material at the foundation level. And in fact, best practice in our experience is to start your preparation for any of the advanced exams by retaking a sample foundation exam. And if you do not pass it, go back and figure out what you're having trouble with and get re-ramped up on the foundation. For people who've taken their foundation in the last, say, you know, 5 or more years, certainly there might be a considerable amount of sort of forgetting of some of the concepts. And even if you took it more recently than that, the syllabus was updated in fairly significantly in 2007, and then was updated, I wouldn't say very significantly, but not a non-trivial update occurred in 2010. So, you know, remember that the extent that it's drawing upon foundation material, we're drawing upon the most recent version of the foundation. So some amount of review is almost always appropriate. You can also see what are called cross-section questions. A cross-section question can join learning objectives and material from 2 or more sections, either in the advanced syllabus or one section out of the advanced and one section out of the advanced, one out of the foundation. So, you know, you have to be ready for that. We've had reports of that. Okay, so a little bit about advanced training courses. I kind of hinted at this before, some of this, and I'll get down to the more detail here. For an advanced training course to be a certified or an accredited training course, it must cover all of the learning objectives defined for the module. So if it's a technical test analyst, training course, then it has to have coverage of all of those learning objectives that are defined in the syllabus for the technical test analyst. Now, here's a big point of confusion, and I want to be really clear about this. There are no common learning objectives between the test manager and the other modules. It's basically, not any overlap there. There's some chapters which are in common, but I think if you look at the amount of timing that's dedicated to those, it's very minimal. So basically, there is no common module, and we are aware that there are training courses that are out there that are offered in this what's called 2+3+3+3 format. I don't know how those things work. I don't know, and I don't care to know, because the analysis that I've done shows that there's just simply no way that those can be doing anything but giving extremely short shrift to some of the chapters which are in common, such as Chapter 6 and Chapter 7 and Chapter 9 and Chapters 1 and 2. Any sort of quote-unquote common module would definitely have very brief discussions about the learning objectives that are specific to each of the three modules. And so, caveat emptor. I mean, we've had people in our courses that came in saying, yeah, we tried to do one of those 2+3 things and it didn't work. It failed the exam. And, so don't do it. It won't. It's not adequate. And you don't have to take my word for it. You can do your own analysis. Take a look at the course outlines and then ask them specifically how they cover some of these things. Excuse me. Here's where that quote-unquote common module is going to get tripped up. According to the accreditation guidelines, then for every K2, K3, and K4 learning objective, there has to be a real-world software-related example given. Now, by real-world, I mean this has to be drawn from an actual project or product, and it has to be non-trivial. It has to be something sophisticated. So, for example, I mean, if we're talking about a K3 learning objective related to achieving a certain level of code coverage, then I would have to show you a piece of code, and it would have to be a real piece of code, not some sort of little like made up kind of academic type of looking thing. It had to be a piece of code that, like open source or something like that, something that does achieve some identifiable objective. And then I would have to show you the tests and show you, okay, this is the kind of coverage that's achieved. Just giving you, 3 or 4 lines of code and saying, oh, look at this, look at that. That's not going to be sufficient. It's not going to help you transfer that knowledge to the real world. You also have to have realistic exercises for all of the K3 and K4 learning objectives, and those have to be done in class for any live instructor-led course. And again, those realistic exercises need to be based on some sort of non-trivial, real-world type of situation. And this is where the common module type of approach is going to really get into trouble, because you're simply not going to have enough time to do the examples and exercises that are unique to each module, and they have to be unique to the module in enough depth to really prepare someone not only for the exam, but actually for real-world transfer of this information. So beware of that. Okay, here is, for those of you who are thinking about taking a course, the hours breakdown chapter by chapter. And as you can see, there's, I'm going to get the magic marker going here. Chapter 3, that's in any sort of live instructor-led course, that's from an hours point of view, that's basically almost 3 days of training, because usually you get about 6.5 days of training time. And similarly, you know, the test analyst, you've got 3 days here, and you've got 2.5 here, and then with 9 and heavy emphasis on 5, there's another day and so forth. So you really see that the time distribution is quite different. The difference between the test analyst and the technical test analyst is that in the technical test analyst, you're focused on the white box stuff more than the black box. So you also do cover black box. There are some common learning objectives between the test analyst and the technical test analyst, and for those of our clients who are interested in doing both, we can combine those together and actually get that done in 8 days without any sort of compromise to the level of coverage. But just to reiterate, the test manager, there is no common module there, so anybody who's saying that you can combine the test manager and the test analyst and get it done in 8 days, then again, I'd say, well, take a real hard look at the examples, the exercises, so forth, and coverage and learning objectives, and just caveat emptor. That, by the way, the next release of the advanced syllabus, the commonality, the material commonality, we completely removed, so there won't be any of that confusion in subsequent releases of the syllabus. Okay, so to earn the advanced certificate, you have to hold a foundation certificate by some ISTQB recognized exam board or member board. Doesn't necessarily have to be the same board as the one that you are about to take the exam from. So if you've gotten a Canadian certificate and you then want to take the advanced exams down in the United States, no problem. There's an experience requirement, which is anywhere from 2 to 5 years, and you get pre-qualified based on that experience requirement, and that's usually a good idea to get that taken care of before you take the exam. And there's also a code of ethics that's given in the syllabus, which has now been moved to the foundation syllabus if you look at the 2010 or 2011 version. You do not have to take training. Obviously, as a head of a company that sells training, we think that it's a good value for people, and that's something that is very useful, and that is instrumental is maybe the wrong word, but is very important for a lot of people in getting through the exam. But that said, is it possible to self-study? Absolutely. I mean, I've written a book on each of the modules. The book on the Advanced Technical Test Analyst is coming out in the next few days. And so you could read one of those books and basically just self-study and take the exam, and people do that. We've had somebody come up to me in Milan, I guess it was, last week when I was there at a conference and say, hey, I took the advanced exam based on one of your advanced test analyst book, I think it was, and he said, yeah, I passed it, and it was fine. So it does require a great deal of dedication, though. Self-study is, obviously, it's a lot cheaper, but it is a lot harder, too, I think, in terms of the amount of discipline. And if you get stuck, you have to unstick yourself. So if you're going to do self-study, make sure that you set aside, usually, the courses are about a week, as I said, 5 days, and we encourage people to do pre-work before they show up. So, you probably are looking at between the homework and everything and taking an accredited training course to pass the exam, it's in the 60 hours of time range, including the classroom work and the pre-work and the homework and so forth, 60 to 80 hours of prep time. I would guess to self-study, you'd have to be willing to dedicate, I'd say, 1.5 to 2 times that amount of time, because when you got to places where you were stuck, as I said, you'd have to unstick yourself. You'd have to go do research or find another book, find another source. But if you are in the situation where you have a lot more time than money, then that's certainly a route that's open to you. Okay, so let's get into why you would benefit from this. What does a technical test analyst bring to the party, as it were? What capabilities do they have? Well, they should be able to figure out how to actually implement a test strategy in terms of technical requirements. So an example of that, let's suppose that you're following a risk-based test strategy, and that there's been a risk analysis done, and you have identified a number of risks to the quality of the system related to performance, response time. So you should be able to then look at those risk items and say, okay, I understand what these risk items mean, and based on these risk items, now I'm going to go off and implement a performance test that adequately covers those quality risks, response time related quality risks, to the appropriate level, appropriate degree of coverage based on the risk. You should also be able to look at the internals of a system, its design, and its actual code implementation, and assess, hey, is this going to work? Again, looking at like the performance example, you might in a particular project be looking at a design and the way that the various components are going to connect together, and say, I don't think that this is going to scale up to the desired level of performance. Evaluate the system in terms of the quality attributes, performance, security, etc. So review requirement specifications, design specifications, user stories if you're in an agile world. From a technical perspective, thinking about things like, again, performance and security and so forth, adequacy of the system to provide those characteristics. You should be able to not only think conceptually about what adequate testing would be in terms of risk and so forth, but also to actually create the tests and execute the tests and report on the status of the tests, pass, fail, blocked, the defects are that you've seen and so forth, in the appropriate level of detail, appropriate degree of information that's necessary for the stakeholders who will receive that information. Should be able to conduct various types of technical testing activities, such as automation of tests and analysis of how to create performance tests, for example. You should be able to have a technical discussion with a programmer, designer, and so forth, and be able to demonstrate why you're making a particular assertion from a test results point of view. So, for example, if you're saying, well, we don't think that the unit testing was adequate of this piece of code, you should be able to say, we've looked at your unit tests, we've looked at the code, and we know that you've not achieved 100% decision coverage or modified condition decision coverage or whatever the standard is. Be able to point to the standard and say, we think that this is the level of testing that really needs to be performed, and you haven't gotten there. And also understand proper use of tools and techniques, be able to look at situation, understand what appropriate levels of automated testing would look like. So the exams and the courses are focused on learning objectives that are all basically traceable back to that kind of those kind of capabilities. So let's, at this point, kind of do a quick dive in, look at some sample course content and also a sample exam question, and give you more of a feel of, well, what would it be like if I took a course, tried to prep for this exam. So as I mentioned, the course has a number of elements, I guess you could say, the right word, where we're looking at how to apply certain testing techniques to the testing of particular capabilities or attributes that we want the system to have. So one of those is efficiency. Now the attributes are defined based on the ISO 9126 standard, which you should remember from the foundation level, assuming that you did that. So efficiency has to do with, as the definition from 9126 says, is the capability of the software product to provide appropriate performance relative to the amount of resources used under stated conditions. So we're looking here basically at things like response time and throughput and resource utilization. The resources can be other software products, so resources like operating system resources, for example. It can be the hardware of the system, so CPU utilization, and other kinds of infrastructure like networks and so forth. Now, efficiency is very important to many users that for any system where speed is a consideration, and certainly that's many systems. Certainly in the cloud, we start talking about cloud-based software, efficiency is extremely important. Now, that's not to say that functionality, reliability, and usability are unimportant. Those are also very important characteristics, but certainly efficiency, if the system does everything right from a functionality, reliability, and usability perspective, but is very inefficient, then that's going to be untenable. Now, when you do testing of efficiency, it's almost always involves a tool, which there's discussion of that in Chapter 9 of the course about setting up tools to do various kinds of efficiency testing. Now, performance testing especially is surrounded by a lot of myths. One is that it's done to break the system. I mean, performance testing is like any other form of testing. It's an evaluation, and you shouldn't. If you go into it saying, well, we've got the system now, and we're going to try to figure out what's wrong with it from a performance point of view. This is not a good philosophical approach. You want to, of course, we want to find defects, and we expect to find defects. But one of the big mistakes that people do or make with performance testing is they wait to deal with performance-related risks until the very end of the software development lifecycle. By which point, they often discover that some fundamental design problems exist in the way the system is set up, and that those design problems prove insurmountable in the little time that remains. And I personally have seen as a contractor at one point as a consultant a bit later, two enormous multi-million-dollar, multi-year, multi-person century type of effort scale projects collapse more than halfway through those projects, in some cases right near the very end of those projects, where the performance turned out to be unacceptably slow, and all attempts to resolve those performance problems via throwing hardware at the problems and so forth just did not work. Projects collapsed, and millions of dollars were lost, and opportunity costs incurred by the organizations are enormous. So that's not what you want to do. You want to deal with engineering in good performance from the very beginning. You want to deal with the performance-related quality risks throughout the life cycle. You also want to make sure that you don't fall into the trap of thinking that performance testing just involves the tool. I mean, we've run into that too. Of I've hired some people who are certified Mercury load runner test engineers, and so that's fine. And then I'll ask questions like, well, how many years of performance testing experience do they have? The answer will be, well, none. We just, these guys do our functional testing, functional regression testing with Quick Test Pro, so we just bundle them off to get some more training, and now they're certified for Load Runner, and now they're ready to go. No, that's that's like saying that a 16-year-old who's just learned how to drive a car is ready to go to Indianapolis or some other famous road race. I mean, that's just not. There's a conceptual level of understanding what exactly you're trying to accomplish with the tool that is very sophisticated and involves quite a bit of experience and really focus to master. Okay, so what are our objectives if we're doing efficiency testing? Well, concurrent usage, very common, particularly, like I said, like cloud systems, sort of multi-user system. Making sure that when you have concurrent users, multiple sessions going, that you have what can be referred to as functional integrity. In other words, that functionality still continues to work properly. When you have multiple sessions going, that the time, behavior, response time, or throughput is as desired, and that the resource utilization under the various levels of load is appropriate and provides adequate safety margin, so that if forecast levels of load are, say, exceeded by some small amount, that you're not going to immediately run out of resources and crash. Now, in terms of what you hear when people talk about doing various sorts of efficiency testing, obviously one of the most common names is performance test. Typically, a performance test is one that's looking at response time under various levels of load or throughput under various levels of load. Load is another name that you'll hear. Load test is where we put the system under some foreseen or maybe extreme level of load. Though extreme levels of load that's often called a stress test. And we just look at various system behavior, sometimes functional system behavior under load. Sometimes response time, though usually if you're looking at response time, that referred to as a performance test. It's a combination of performance and reliability tests that's done, it's sometimes called an endurance or soak test, which is running the load for an extended period of time and monitoring the resource utilization to make sure that it's not leading to a level of overutilization or potential overutilization that might cause reliability problems. So reliability is a little different than performance. In the case of reliability, you're not so much concerned with response time. You're more looking at resource utilization and, of course, is the system actually staying up, and are the various applications that are running or sessions that are running, are they all staying active, and so forth. Some other names that you'll sometimes hear, background test. Background test usually has to do with putting the system under load while you're functionally testing it. Spike tests are where they're a form of stress test where the high and often exceptionally high levels of load are inflicted on the system in a spiking fashion. It simulates, in the case of a cloud-based system, a distributed denial of service attack in some ways, and you can see how the system would respond to that. Scalability is a name that you'll sometimes hear. Sometimes that will refer to a test where you're looking at the ability to dynamically reallocate various resources, say, in a virtualized server. Tip-over test would be a type of load test where you would actually load the thing to its foreseeable maximum load and then continue beyond that to the point where failures started to occur, all the way up to the point where the system actually crashed. And the idea there is look at, well, what's my margin of safety, and what happens when the system does crash. Any system, once it gets to a certain level of load, will crash. So the question is whether it does so in a way which is unacceptable, for example, by corrupting data or something along those lines. Okay, so I mentioned that just understanding how to use a tool when you're doing performance testing by itself is not enough. You need to do what can be described as modeling of the system. So you need to understand what's in scope and what's out of scope from a test point of view. You need to know, okay, how many concurrent users are we going to have? How many sessions at one time? And there's normal versus peak, and of course that's often time variable with systems. So based on the hour of the day of the week, the day of the month, the month in the year. For example, e-commerce systems going to tend to see, consumer-based e-commerce systems anyway, going to tend to see a much higher level of load in holiday periods than those non-holiday periods. Configurations that need to be tested if there are multiple supported configurations. Application mix, so what else is going on the system. That's system workload mix. Application mix, we're looking at there's what type of activities are on the application. So you think of a set of servers that are providing, say, hosting an e-commerce site. There's probably other software beyond just the web server, the application server, and the database server running on the particular hosts. So what is that mix? And then on the application itself, how many people at any given point in time are browsing, how many people are in the process of starting a checkout session, how many people are actually completing a payment, all of those things would be things you would need to understand and have modeled. And again, that kind of thing tends to vary based on, as I said, time of day, day of week, day of month, etc. Back-end batch processes that might kick off. So, are there periodic virus scans, disk defragmentation, database cleanups of various sorts, backups, and so forth. Very important to understand that. Also important to understand how closely the test environment matches production, and to the extent that there are differences between the performance test environment and production, what effect will those have on the test results? Now, efficiency testing is quantifiable, and in fact it's sort of almost over quantifiable. There are many different metrics that we can look at as shown here. When I say over quantifiable, what I mean, and this is why just understanding the tool, one of the reasons why that's definitely not enough, is you can measure all sorts of stuff, but you've got to pick the right things to measure. Otherwise, you might see response time slow down, but the things that you're looking at, the resources, for example, that you're looking at, might not give you any clue as to where the saturation is. So then you have to redesign the test and run it again. So, it's important to have these models and understand, okay, here's where we think the backlogs are going to be, et cetera. As I mentioned before, certainly you do not want to wait to the end of the life cycle to think about efficiency. This is something that needs to be engineered in and tested throughout the life cycle for any system that, at least where that matters, where efficiency matters. So we can do efficiency testing at the unit test level, at the integration test level, as well as the system test and system integration test levels, and that's important to do that. It's all too often that people say, oh, well, we can't really do anything about that until the very end. Well, no. Don't fall into that trap. All right, on this slide you see some fairly typical types of performance problems that you will see during a performance test. Let me spotlight here. Well, we'll start in the upper left and work our way around clockwise. So let's say that for all four of these graphs, what you see is the transaction processing time in seconds. So that's how long it takes from submission of a transaction to completion of the transaction. And our target is that we want them done in 1 second. And transaction arrival rate in terms of transactions per hour is 1,000. Okay, so that's our average transaction arrival rate. We want to be able to as I said, support up to 1,000 transactions per hour. So that's this gray box right here. This is the zone of acceptable performance here in the gray box. So this first scenario shows a situation where the system response time is unacceptable regardless of the level of load. So as we start moving towards that 1,000 transactions per hour rate of transaction arrival, you can see that we suffer a linear degradation of response time that is always longer than 1 second. So that's obviously a problem. Another thing that maybe is more common is what you see here, which is the response time is acceptable up to this point, which is about 250 or so transactions per hour level of load, and then we get a resource saturation. And I apologize for the figures kind of being corrupted here. This oval should actually be right over that. So we now have resource saturating, which means that one or more of the resources that is involved in processing those transactions, typically it's hit like an 80% allocation rate. That's usually where you start to see bottlenecking. And it slows down so that once we get above about 500, here we're beyond the one second time, degrades, and then we hit a second bottleneck here, and the degradation becomes more severe. And many times this can be really severe, so you get what's called the hockey stick effect, where it's flat or flattish, and then you hit this bottleneck, and this shoots straight up. This is actually pretty mild comparably. Now this one shows 3 different response times, presumably measured at different tests. 3 different performance tests run, and we get a situation where first performance test is pretty much okay, but then the subsequent 2 are showing some amount of degradation. These are being run over time, then this could indicate a issue of resource exhaustion, such as associated with memory leak, or it could indicate background loading that's going on that's affecting the response time. And then you could see this response time is sometimes acceptable and then sometimes unacceptable, and it kind of goes back and forth between those based on the background load. And then what we see here in this last figure is that the system is okay up to a certain point. We get our resource saturation, and then the response time is okay, but what we start to see is its error handling capabilities start to degrade. So that's confronted with any sort of error input or something like that, you don't get a meaningful output. You've probably seen this with websites when sometimes the websites get loaded down and you do something illegal, it just nothing happens, or you get a timeout or something like that, because it can handle things that it's expecting, but as soon as you do something unexpected, it doesn't handle it. We see the performance continue to degrade, and then what can actually happen, which is kind of interesting under high levels of load beyond peak, is that you actually see the response time start to improve, but what that often means is that just immediately the transactions are being rejected without any sort of processing at all. So the transaction appears to have completed, but in fact it's just failed to take place. So those are all fairly typical types of errors to expect to see, or failures to expect to see during performance testing. Okay. Now we can talk about, and ISO 9126 talks about internal metrics versus external metrics. Internal meaning stuff we can look at in terms of the internal quality of the software, the intrinsic quality. And I've mentioned some of these: response time, throughput, the turnaround time, various resource utilization metrics. And then 9126 also talks about external metrics, ones that are sort of externally visible, if you will. And obviously there are a lot more of them. And as you see, there's a tremendous amount of metrics here, and there's a discussion in the course about, in much more detail, about how to go through and select which one of these you're going to be looking at during your testing, because you just say, well, I'm going to capture all of it, and what you're going to find is you've got so much information, and it's just, you don't know where to start if you see problems, and where should I start on this thing. Okay, so here is a sample exam question that lets you think about. It's something that you might see on an exam. It's relevant to the material some of the material we just discussed. Let me go through this, and you can write down your answer, and then during the question and answer session, we'll see who got the right answer. Just write down A, B, C, or D, and know that it won't affect the e-learning drawing, I'm afraid to say. So let's assume that you've run your performance test. You're evaluating your metrics, and what you see is every 10 seconds, CPU utilization on the server jumps up to 80 seconds and persists there for about 80 milliseconds, drops back down to 40%. So your service level agreements in design requires that the CPU utilization be 80%, less than 80% at any given point. 80%, as I mentioned, is where you start to see bottlenecking. So what should be your next logical step? Should you, A, determine the background loading on the system by looking at the top active processes when the spikes occur? Should you, B, check for memory leaks on the server? Should you, C, check the mean occurrence of error metric during the run? Or should you, D, ensure that the transmission capacity utilization metric on the server does not drop? I'll leave that up for another minute. Look at it, and as I said, write down your answer. Okay. So that concludes the presentation proper. So at this point, I'm going to answer any questions from the audience that you might have. If you have not already started to do so, please submit your questions using the webinar Q&A feature. Let me go ahead and get the questions pane undocked here so that I can actually see the questions. Whoops. Now that wasn't what I wanted to have happen at all. Okay. Let's see. All right. So a question here. I asked, I don't see any slides, just the overview page. Where do I log in to see the slides? That's unusual. I guess that that was when somebody logged in before I started screen sharing. If anybody's had any difficulty with seeing the slides, please let me know what exact symptoms you had. This is the first one to me. I've never heard this. Keith, you're still here. I'm so sorry that you did have that problem. Okay, the question from Harrison says, you indicate that training courses must have live instructor-led courses and include real exercises. Does that mean that any e-learning course is therefore automatically not an accredited course? No, you can get an accredited course, an accredited e-learning course, and we do have them. We have all three. But the requirement is that for instructor-led courses, it's not okay for the instructor to simply say, here's an exercise that you need to do for homework, and send people off to do it. And the reason for that is that our experience has been that when people are taking instructor-led courses, if the exam is going to occur at the end of the course, the people will not spend whatever free time they have in the evenings doing exercises. They will spend that time doing whatever they're going to do to prep for the exam. And that becomes more and more pronounced as you continue on through that week. And then the problem would occur is that somebody would potentially pass the exam, but because they hadn't done the exercises, they would have no capability of transferring that knowledge into the workplace. So it's important that the exercises be done in the class. Now, for the e-learning, the way that works is that the exercise is assigned, but the solution is also provided, and there's a debrief of the solution, so that and in detail, so that you really do understand this is how the solution works, and that's the way that's handled for e-learning, and that can also be augmented by having people take some sort of like webinar class session or boot camp or something. Like we're doing a foundation boot camp tomorrow, where we're going through the syllabus itself. That can also be like targeted at going through exercises and so forth. So there are various ways to add that component. A question here from Melinda. Good day. Regarding common modules in the 3 advanced level courses, if there are no commonalities, how come there are software testing training companies who provide these courses with a split 2+3+3+3 approach? And these companies' course materials was approved and accredited by ISTQB. Well, so just to be clear, the ISTQB itself does not accredit courses. The different national boards accredit courses. If you are looking at a situation where you believe that there is course material that does not meet the accreditation guidelines, well, there's a couple things you could do. One is, of course, don't take that training, and if you're a manager, don't send other people to take that training. If you think it was accredited in error, then you can raise a complaint to the national board, whatever national board is applicable, and say, hey, we don't think that this should have been accredited because we don't see how this can possibly cover the learning objectives that are defined for this module at a particular level of depth. But more importantly, for your own personal decision making, your own personal educational needs, and then for those of your staff, if you're a manager, what I'm telling you is that if this is a very simple exercise. You don't have to take my word for it. Get the advanced syllabus and look at the 3 different sets of learning objectives that are defined, and do an analysis and see where the commonality is. And you'll see there's commonality between the test analyst and the technical test analyst to some extent, such that you can do a 2+3+3 for the advanced test analyst and the advanced technical test analyst, which we indeed will do for our clients. But you cannot do a 2+3+3+3 for the test manager and the 2 test analyst modules, because there simply is no commonality in terms of the learning objectives. So the requirement is that the examples and the exercises be pertinent to the specific module that's in question. So if you think about, with the test manager perspective versus the test engineer or test analyst, if you prefer, it's totally different perspectives, even if you're talking about the same process or same topics. So, I don't want to get into the, back room issues of what, how this might have come to occur in any particular case. But what I'm saying is that for those of you who are going to take courses, if you're considering such an approach, then, if it's going to be, if that common module is being said to be common across both test manager and the 2 test analyst modules, then I think you can, ask hard questions here about how exactly are you covering those K2, K3, and K4 learning objectives with examples and exercises in a way that's actually pertinent to the module in question, test manager, test analyst, and technical test analyst in the common module, because you would seem that instead of having one example for a K2, K3, or K4, you'd actually have to have 3 examples for that were pertinent to that particular module, which would then, I don't see how you do that in the 2 days without having just this incredible blow up in terms of the amount of time, or this incredible compression in terms of how much time you spend on the examples and exercises. Excuse me. Okay, got a question here from Keith. Keith Stobe. Keith, good to see you. Stress and tip over would seem to be done to break the system, so performance myth and this are somewhat contradictory. Okay, fair point. Let's go back to that. Where that was? Yeah. Okay, so I guess if you say, Keith, that by break the system we mean to find the point at which the failure occurs, then yeah, I guess that's probably a fair thing to say. I think the way that this is meant, that when it says the myth here, the performance testing myth of breaking the system, I think it's more along the lines of finding how exactly to put this. There are some people that I think the approach to this could be, well, we're not going to worry about performance, we're not going to worry about efficiency until the very end, and then we're just going to go in and we're going to find out what's broken from a performance point of view, and tweak that, and then we'll be done. And that's not really a good approach. That's more of a well, it's another manifestation of one of the worst practices of testing, which is testing on the assumption that nothing really bad happens, that there aren't going to be any bugs, or if there are bugs, they're not going to be that serious. And my own experience with this is that you see these bugs, and they are actually quite serious performance-related bugs, often to the extent that they can actually kill the project. Okay, so in terms of the answer to the question, we have various answers coming up here. Whoops, let's go to the question here now as I see the answers coming up. Okay, so Katya answers A, and then we have Keith is answering B, memory leaks on the server. Ehab has answered C. Well, I would say the answer is A, personally. That's what we have as the correct answer in our course, because if we're looking for spike situation where the CPU utilization has jumped up and then dropped off, and then we would think that maybe during those spikes that that something is kicked off in the background, or has flared up in the background, if you will, to consume a lot of memory. If anybody wants, or consume a lot of CPU, excuse me, anybody wants to debate that here, I'm happy to take a question on that. Let's see. Oh, Keith says changed from IE9 to Chrome. Now that's very interesting. You're saying IE9 is incompatible with GoToWebinar. Thank you for that piece of information, Keith. We will certainly follow up on that with Citrix and see if they've had any other reports of incompatibility between IE9 and GoToWebinar and ask them to research that. So I appreciate that. If anybody else has had any sort of visual issues today during the presentation, please do let me know, because we do take these very seriously, and we'll escalate them up and try to get them fixed. By the way, there's a blog posting on the RBCS blog, rbcs-us.com/blog, that explains what happened in terms of the audio glitch that occurred in last month's webinar. So if you're a victim of that glitch last month and want to go check out the information about what exactly happened, what the combination of bugs was that caused that to occur, check the blog. Let's see, Esther, I apologize if I missed it. What was the correct answer to the question? The correct answer is A. Alan asks, can I get the audio of this webinar? Yes, actually, there are two ways that you can go about accessing this webinar after we're done. This session is being recorded, and a recorded version of it will be posted on our digital library. So that's rbcs-us.com/resources page. You go to the digital library, find this, and all the other webinars are recorded there and available, so you can actually hear the audio and see the slides going at the same time. And it's also posted on the RBCS YouTube channel as well, so you can go to the YouTube channel and subscribe, and you can catch those as they come out. In addition, we post these as podcasts. So if you subscribe to the RBCS podcast on iTunes, we post those MP3s. So that's audio only. But if you have the PDF version of the slides, of course, with the audio, you should be able to follow along. Harrison asks, did you spend the bulk of the webinar on efficiency testing because that is highly stressed in the CTAL-TTA, or just as a way to show material to a sample question? Yes, it's just a way to show a sample of the material. I thought that rather than going at the 10,000 foot or more like 100,000 foot level overview of our 5-day-long course, where you really wouldn't have gotten a feel for anything other than these are the topics covered in the course, and these are the exercises you'll do, and so forth, which to me it seemed like that would feel more like a advertisement for our course, which I try to avoid, just doing that kind of blatant commercial stuff on these webinars. What I wanted to do was say, okay, well, this is the kind of depth of coverage that you can expect if you take a course or read a book or in some other way prepare for the exam. So it was more like I picked a chunk out of the discussion about efficiency and actually went through it, and basically the similar depth as what we do in the class, and hopefully that does give you some feel. But is efficiency likely to be heavily emphasized on the exam? I think what I would, instead of speculating on like what percentage of questions you'd expect to see that are efficiency related, Harrison, what I would recommend is get these advanced syllabus, look at the learning objectives, and look at the timing allocation. And I showed you the timing allocation earlier too, so you can go back and refer to that in the PDF version of these slides. Basically, the exam questions are going to be based on the learning objectives, and the distribution of the questions can be more or less proportional to the timing that is allocated. So you can look at what percentage of time is spent on each chapter. You can say that that's about what percentage of exam questions that you would be likely to see related to that chapter. So that's probably a better way of figuring out what's going to be heavily emphasized. I mean, and if you do that, of course, what you'll see is that, you know, chapter 3 is, you know, it's probably almost half of the exam. Chapter 4 is almost half of the exam at the technical test analyst level, with some fairly significant material from chapters 5 and 9 as well. So that's really the better way to go about it. Harrison says, what was the answer to the sample question? You submitted this question, Harrison, before I'd given the answer, but the answer is A. Luana asks, if you don't currently perform load/performance testing but are familiar with automated testing, do you recommend taking the test analyst or technical test analyst? Luana, I think you do fine if you're, I mean, don't be scared off by the fact that I spent time talking about performance testing and load testing. That's one of the things that's covered. But if you've got solid experience doing automated testing and from a functional perspective, I don't think you should be frightened off from the technical test analyst at all. Now, I would say that one of the things that we have found that is very valuable for people taking the technical test analyst courses and the exam is the ability to read code, be able to read a programming language. It doesn't matter too much which one that is, though, you know, obviously you're going to be better off if you know one of those modern structured languages like C or C++ or Java, rather than you know, just something like Fortran or COBOL or something like that. If you know how to read scripting languages like, say, Ruby or Perl, is that enough? Yeah, probably. I mean, you need to be able to understand things like conditions and branches and loops and the concept of an executable statement. Otherwise, I think you'd spend a lot of the time in the course really feeling kind of flummoxed by some of the very highly technical material. So if you don't know how to program, what I'd recommend is, I think to be a tester for any length of time now, given what's going on with, you know, prevalence of Agile and so forth, you really do need to know programming languages. So I would say get a book on, you know, basic programming, not basic language, a basic book on programming like, you know, programming in C or Java or something like that, some sort of introductory text similar to what would be used for a first-year computer science student. There's enough open source development environments out there that can be gotten for either Windows or Linux systems that you can get yourself a development environment, and including coverage tools if you want, and you can teach yourself to program. And I would say that's probably a good first step if you do not know how to program. Okay, Jason asks, how long is the exam and how many questions are on the exam? The exam is 3 hours, and there are 65 questions on it, which at first you might think, oh, well, that's easy because, you know, the foundation was 1 hour and then there were 40 questions on it, so, you know, that's a lot fewer questions per minute. That's true, but that's because the questions are a lot harder. Now, we've had people that have told us, oh, you know, I took the exam and I was done in the space of 2 hours and I left. We've had other people that have told us, yep, took the exam and, you know, I used every single one of the 3 hours. So, you know, it just kind of depends, I think, on how well prepared you are and also your kind of approach to taking exams. Pardon me, I had to get a drink of water there. Carabo asks, I have a business as opposed to a technical background. Even with my 7 years testing experience, I will surely struggle in this area. Is there hope for my expert level ambitions? Okay, good question. So, could you learn to master the technical details and get the technical test analyst even if you had no business or no technical background? Yeah, you could. As I said, I think if you taught yourself programming, and you had solid testing experience, you'd probably be in good shape. But you do not have to get all three of the advanced level certification to move on to the expert. Doesn't work that way, because the career path branching occurs at the advanced level. And what that means is that, for example, if you want the expert test manager, which we just did the beta release of 2 weeks ago at the ISTQB meeting, or the expert at improving the test process, which is also likewise out. The prereq for that is the advanced test manager only. You do not have to have the advanced technical test analyst or the advanced test analyst for that. In fact, I'm hard pressed to imagine any of the expert level modules that would actually require all three of the advanced level modules. It's possible, but at this point, no such expert level modules are in the works. There's a test automation module that has the advanced technical test analyst as a prereq, naturally enough, and I believe the security one might have the technical test analyst as a prereq. But for the expert test manager, Carapo, if that's what your ambition is, you don't worry about it. You just need to get the advanced test manager for that. Question from Angel Telez. Good to hear from you again. I hope all's well with you up in Canada. I got the AL manager a few weeks ago. Congratulations on that. What's the recommended next advanced level certification that I should take? Really kind of up to you. What do you do, I guess I would say, and I mean, if you're a business-focused tester, or you're managing people who are business-focused, then it's more test analyst. If you're managing people that are more technical in their focus, or say you're going into an agile position, agile role, and you're going to be working very closely with developers, then maybe technical test analyst would be the better one to go. Now, if you are going to do both of them, what we've typically recommended to people who are going to get both the test analyst and the technical test analyst is take the test analyst first and then take the technical test analyst. I'll tell you why. Some of the learning objectives that are covered in the technical test analyst are also covered in the test analyst, but not so much vice versa. In other words, the technical test analyst, so you can do this by looking back earlier in my slides, it just includes more learning objectives than are covered at the test analyst, which means that the test analyst is, I could say, easier, but there's fewer topics to cover, and some of those topics are recovered in the technical test analyst, which means that you can kind of focus your studying time and attention at the technical test analyst on those white box concepts that are new. So just to recap that, if you're going to take both the test analyst and the technical test analyst, I would recommend test analyst first, and then technical test analyst second. If you're going to take just one of them, then pick which one you take based on which is going to be most useful to you in your business. Let's see. Angel also asked a question about what's required to take the expert level certification. I believe they answered that. Now, and just is it maybe I'm mispronouncing your name? You can educate me here. Perhaps the name is Angel Telez, if it's Spanish. So send me a comment. Let me know if I'm saying your name wrong. Okay, so Ehab asks. Ehab says, I took the foundation course, but when asking a practical question, couldn't find any help. The advanced level is focused on practical rather than theoretical. So as far as the foundation, what we have found is it depends a lot on which course you take. all of our courses are very much designed to include practical hands-on elements in the exercises. This has been kind of a business problem for us because we tend to run our foundation course, unless the client insists, we run it as a 4-day course rather than a 3-day course, because what we do is we include practical real-world exercises for every chapter in the foundation. It is possible to take foundation in a 3-day version, which as a practical matter usually means 2.5 day, because the second half of the last day is spent taking the exam. Yeah, that's likely to be not so practically oriented because you're trying to rush through a bunch of material to get people ramped up on what they need to know for the exam. And this is why at the advanced level, when we wrote the accreditation guidelines, I said, hey, listen, you know, we have to have exercises and they have to be done in the class, because this idea of just assigning them as homework and assuming people are going to take them is, you know, not something that's worked at the foundation level. But to answer your question more directly, is the focus on practical rather than theoretical at the advanced level? Absolutely. In fact, when we wrote the original version of the advanced, and then now as we're working on the new version, the question that we ask over and over again is, you know, is this practical? Is this concept, technique, et cetera, in real world use somewhere in industry? If the answer is no, we didn't include it. Let's see. Jose says, I've read about the QAI, or Quality Assurance Institute certifications, found them very complete and interesting. Is there a way you can point out some of the pros, ISTQB versus QA Institute? This is not adequate for the webinar. I totally understand, but would be curious about the answer. Well, let me just try to be brief about this. You know, evaluating, and I talked about certifications and evaluation of certifications in a previous webinar, the recorded version of which you can hear, and I addressed this subject directly. But I mean, I think the short answer to this is, you know, if you look at the learning, if you look at the body of knowledge or syllabus that's defined for any of the certifications, and just ask yourself, well, how pertinent is that to me? And look at some of the reference books that are listed for the certifications and ask, you know, looking at these books or having read these books, do these describe the way that a way of testing that would work for me? And if the answer is yes, then, you know, then that's fine. Now, I would point out from a training point of view, QAI is a closed system, and ISTQB is open. And what I mean by that is, basically, QAI, to the extent that you're going to get training for the QAI certifications, is coming from QAI. They claim to have a way of getting courses accredited, but we've tried that. RBCS has tried that, and we've asked about accreditation for our courses, and it's not only we weren't told no, we simply were not even responded to. So I think that speaks pretty loudly about, you know, is their program in part about selling QAI training? And I think the answer is pretty clearly yes. Now, maybe you don't care about that. Maybe you're like, hey, just, you know, I just want to get whatever certification's best, and, you know, I don't care about the fact that there's no competitive market for training. And see, in the ISTQB program, there's a very open, competitive market for the training. So if that's something you care about, then that would be a major pro. Excuse me. David says, stress testing is not to break the system per se. It is more to see at which point the system breaks and thereby establishing the system hardware limits. Yes, yeah, I would definitely agree with that characterization, David. I think that's the way I would think of it too. Okay, Gail says, I am on the website but can't find the slides. So look at the resources tab, if you will. It's like in the upper center of the rbcs-us.com homepage, and you pull down resources, and then it'll say library. You go to library, and then go to the basic library, and you'll be able to find the appropriate slides there. Let's see. Keith says, would garbage collection show up as a different process than the expected application of top processes? This is with respect to the sample question here that's still up on the screen. That's a good question. Yeah, now I see your point, Keith, that if Yeah, if garbage collection were the problem, would A help you find it? Well, maybe, yeah, maybe not. If you had periodic garbage collection going on, so that's an interesting point, that it might not show up as a separate process. Now, certainly it's background loading. It's a background loading issue, but you're right, it might not be visible that way. So that's kind of a possible exception to that. Let's see. Carabo asks, does a basic visual basic course in terms of programmer training suffice for technical test analysts? You know, I was trained at UCLA to see BASIC and all of its derivatives as this is my computer science degree there. That was like the most obscene form of heresy. So I'm probably the wrong guy to ask about BASIC or any of its derivatives. I mean, I think if you were taught an approach to Visual Basic that actually involves structured programming, then it would probably be sufficient. Okay, Jeremy asks, which of your books do you recommend for the technical test analyst? Our technical test analyst book is Advanced Software Testing Volume 3, and it will be out in the next couple weeks. You can actually pre-order it on Amazon right now. Priya asks, will the advanced level exam consist of all three parts, advanced technical test analyst, test manager, and test analyst? No, it's just one. So you take a 3-hour exam, and it's focused on one of the three modules, either the technical test analyst, test manager, or test analyst, test manager, or technical test analyst. It's one of those three. See, Chris asks, got on late. Is it possible to get the slides online? Just mentioned, Chris, where to find them. Hopefully you can find them on the website, and as I said, you can find the recorded version on the digital library or on YouTube. Oh, okay. Here's a comment from Angel. That's the correct pronunciation, Rex. Thanks for your answers. Okay, Angel, I now have that correct. Remember that is a Spanish name, Spanish language name. Let's see. What is the recommended book for the Advanced Test Manager? Well, I like my own book, Joe, the Advanced Software Testing Volume 2, I believe it is. And in terms of the Test Analyst, I recommend the Advanced Software Testing Volume 1. Okay, great. So we're a little over time, but I had great questions, so I wanted to get to them all. Thank you for those excellent questions. To close this webinar, let me tell you a little bit more about the resources available through RBCS. We run these webinar sessions once a month, so please check our website, rbcs-us.com, to sign up. We'll also send you invite based on your attendance at this webinar, though you can always unsubscribe from those invites anytime you want. That's the same newsletter discounts. If you want a special webinar presentation for your company only of this webinar or any other topic related to software testing, send an email to info, at rbcs-us.com, or contact us via our website. If you do not already receive our regular free newsletter, you can sign up at rbcs-us.com. I believe it's at the bottom right of the page. By signing up, you'll get valuable discounts on consulting and training services, a regular newsletter that includes a featured article on software testing and quality, and also news about RBCS and what we're doing. And you'll get invites to these free webinars. So again, you can always just check the website and sign up that way. You can follow us on Twitter, twitter.com/RBCS, and or just at RBCS at Twitter. On Facebook, we're at facebook.com/pages/RBCS-INC. Remember to check your email over the next couple days. You might have been the lucky winner of a free e-learning course from RBCS. You were registered for a random drawing for such a course simply by attending this free event. Finally, check out our new digital library with recordings of these webinars, podcasts, and videos. You can subscribe to our podcast via iTunes by entering RBCS podcast into the search string, or see the videos and recorded podcasts by subscribing to the RBCS channel on YouTube. We offer these free resources as a service to the software testing community because RBCS is a not-just-for-profit company. That concludes today's webinar. I'd like to thank everybody for joining us today, and have a good rest of the afternoon or evening or morning, wherever you are.